Here's another equilibrium problem in which we'll have a chance to use the solver feature on our calculator. Let's start by writing the equation. Don't be scared by the strange formulas they give you, especially for Hw18 Q2+. That's called a complex metal ion, and we'll talk about that in class. But for right now, suffice it to say that it's a metal ion complexed with another ion called thiocyanate, which together, so it's already a polyatomic ion. Now you're attaching a metal, and all together it carries a charge that represents that whole collection of atoms. If we were asked to write an expression for K, we'd say, okay, products over reactants. Notice that the coefficient for everything is 1. That helps to simplify things. And they give us a numerical value for K, which we'll come back to in just a minute. And they did give us the initial concentration right out. They said 2 molar FeSCN in the ice table. So why don't we go ahead and list that out? 2 molar. And since they didn't specify either Fe3 plus or SCN minus, it's safe to presume that those initial concentrations are 0. Okay, so now we've got equilibrium expressions for each species listed in terms of X. Let's go ahead and plug that into our expression for K. So x squared over the quantity 2 minus x would all be equal to the value of K that they gave us up at the top, which is 9.1 times 10 to the minus 4th. Now, at this point, you could use the quadratic equation to solve this. You'd be welcome to do that. Or we could use the solver feature on our graphing calculator. Let's give that a whirl and see what happens. So, in the graphing calculator, when you're trying to enter an equation for solving, it requires you to type it in the format 0 equals something. In this case, we have x squared all over the quantity 2 minus x. And then we're going to close that parentheses and then subtract 9.1 times 10 to the minus 4th. When you go to enter that expression into your calculator, be sure to pay attention to the parentheses, as that will throw off your answer if it's not entered very carefully. After you're typing in the equation, hit enter, and then hit the alpha button and enter, which tells us that we need to, that says solve. If you look at the enter button, the colored wording above it that matches the color of the second button says solve. And when you do that, you should see some blinking lights in the upper right screen of your calculator, and eventually it'll give you a number. When you get that number, first of all, scroll all the way to the right, because sometimes your calculator, certain types of Texas Instruments calculators, will include an exponent. Like at the end of the long decimal, it'll say E5, which means times 10 to the 5th. And double check that that's whether or not that's happening in your case. So here we've got, in this example, 0.042, and there is no exponent at the end. So that means we've got equilibrium concentrations of thiocyanate ion, of iron 3 ion, because according to our ice table, at equilibrium, those concentrations are simply equal to x. And since we know that x is 0.042, we've got those. Now for the iron thiocyanate, the FeSCN, here we're going to take 2 minus 0.042, and that works out to be 1.96 molar. So now we have our equilibrium concentration of FeSCN, of Fe3+, and Cn-.